Hello everyone, and now it is time to compute some limits with transcendental functions. So, as I've mentioned a little bit already, and we're going to start this video with this remark. If you have to compute a limit, okay, with exponential, logarithmic, or trigonometric terms, you should really just approach it as any other limit. Okay, so it really starts first by doing a evaluation of your limit at a number or at plus or minus infinity, depending on your question. You will either get a value and then the question is over and you smile like an idiot, or you will get one of the bad form. So be careful though, there's a brand new form. If you get ln of 0, this is the third and last indeterminate boundary problem that you need to consider. I'm going to go over the steps in a moment. And if you cannot solve it by using the laws or by algebraic manipulation or etc., then you have to rely on the numerical approach. And actually here, every time you're going to see this, boom, little symbol, it's because I'm going to be using the numerical approach to guess my limit. I'm not going to do any tables. In this section, I will just let my listeners the chance to create your own tables and verify that your guesses are matching my answers that I'm just going to feed you here. Okay, so we've already went through the numerical approach. So here's the last indeterminate boundary that you need to consider, and really ln of 0 is going to be approached the exact same way as the square root of 0 or a division by 0. So indeterminate boundary 3, ln of 0. So to study a ln of 0 problem, the first thing that you do, and it's really the same approach as square root of 0 or division by 0, if it's a two-side limit, you need to define the left and the right limit, and you need to compute them separately, and then, of course, afterwards, compare. For those one-sided limits, so if you have a left one to study, then you have the green light to plug a minus, which is, of course, a symbol that represents something that is slightly smaller than a. And if you have a right limit, then you are allowed to plug in a plus, which represents a number slightly bigger than a. And then you're going to, of course, evaluate your expression, and then there's two possible output of this manipulation. Your equation will either simplify to ln of 0 plus, which will blow up to minus infinity, or your equation will simplify to ln of 0 minus, and then that term is just undefined. Okay, and then if you have a two-side limit, you compare. Maybe on both sides, you're going to get minus infinity, and then your two-side limit is minus infinity, or on both sides, it's going to be undefined. That's kind of scary. And then your limit is also undefined. All right, so now let's do it. Let's do some examples. All right, so let's get into it. So here's some examples. So first, we have the limit as x goes to 1 of 1 minus ex over x. So let's just try it. So let's plug 1 in it and hope for the best. So we get 1 minus e to the power of 1 over 1. So over 1. And then, of course, you just get 1 minus e. Wait. So you just get 1 minus e, and that's just a nice number, and there's nothing you can do. That's the answer. Okay, so next, I'm going to plug 0 now. We have the same formula, but the limit as x goes to 0 of 1 minus ex over x. So you get 1 minus e to the power of 0 over 0. E to the 0 is 1, so you get 1 minus 1 over 0. Whoa, z over 0, that's pretty bad. So you get the form, the bad form here. And here 1 minus ex over x, even if you're wearing your black belt in algebraic simplification, there's nothing you can simplify here. You have no choice, okay, to go with boom, okay, a numerical approach. So if you're using two tables, okay, so you need one table going to the right side of 0 and one table for the left side. You can conclude, okay, that the limit as x approaches 0 of 1 minus ex over x. So of course, do it as an exercise here is actually minus 1. Okay, so you get minus 1 for that one. Next example, the limit as x goes to 2 of ln of x over x minus 1. So let's try it. So you get what? So you get ln of 2 over 2 minus 1. 2 minus 1 is just 1, so you just get ln of 2. So you get your answer by simple evaluation. Again here, the evaluation process is very important because either you get your answer or you get the bad form and you know how to react. Okay, so now the limit when x goes to 1 of ln of x over x minus 1. So if you plug 1 in here, ln of 1 over 1 minus 1, ln of 1 is 0. 1 minus 1 is 0. So, okay, so you get a bad 0 over 0 problem. Okay, so that's bad. So again here, boom, I'm going to use a numerical approach. So remember, you need here two tables, one on, let's see, the left side first, one on the right side. And once you've done those two tables, you will be able to verify that actually the best guess here for your limit is 1. So the limit as x goes to 1 of ln of x over x. Again, do it as an exercise. Build your two tables, okay, with 3 values, getting closer to 1 on the left side, getting closer to 1 on the right side, and check that the outputs are getting closer and closer to 1 also. So the guess here is 1. Remember, we're just guessing with the numerical approach. Let's do more since we're on a roll here. So let's plug next example, the limit as x goes to infinity of 1 over 1 minus ex. So let's try to plug infinity and see what happens in that case. So you get 1 over 1 minus e to the power of infinity. E to the power of infinity is infinity. 1 minus infinity, that's minus infinity. Any number over plus or minus infinity is always 0. We could comment here that this equation, 1 over 1 minus ex, has a horizontal asymptote as x goes to infinity at y equals 0. So now, same equation, but we're computing the limit as x goes to minus infinity of 1 over 1 minus ex. So let's just try it here. So 1 over 1 minus e to the power of minus infinity. Be careful. E to the minus infinity is not minus infinity, it's 0. Look at the graph, and then you get 1 over 1 minus 0, which is 1 over 1, which is just 1. So the limit exists here, and it's 1. Remark here, this equation, so same equation for E or F, but they have different horizontal asymptote. To infinity, the function gets closer to 0. To minus infinity, the function gets closer to 1. Okay, so keep this in mind, of course. And now for the next example, now we're going to finally combine some of those problems. So if you plug 0 in that equation, so we have to compute the limit as x goes to 0 of the square root of 1 minus ex. So let's try it here. So you get 1 minus e to the power 0, all that inside of square root. Of course, square root, always be aware of your surroundings, young Bruce Wayne. Okay, so potentially a square root of 0 will appear, and it will. E to the 0 is 1. And 1 minus 1 is 0, so you get the square root of 0, the return. Okay, so here, a nice square root of 0 for your limit. So it's bad, so we need to investigate what's up on the left and the right side. So bad, bad, bad. So let's compute. So let's define first the left limit. So let's define the limit as x goes to 0 minus of 1 minus ex square rooted. And again here, for those bad indeterminate form, if you have a two-sided limit, just writing down first those left and right limits is worth a lot of marks. It really shows you understand what you have to do with these limits. Now for the first one, let's plug 0 minus. You get 1 minus e to the power of 0 minus. E to the power of 0 minus, using the graph or your calculator, you will get something very close to 1, but smaller than 1. So you get 1 minus square rooted. 1 minus 1 minus, that's 0 plus. And the square root of 0 plus will go to 0. So the left limit is 0. What about the right limit? So if you plug 0 plus, you get e to the power of 0 plus. E to the power of 0 plus is a number close to 1, but slightly bigger. Use your graph. or your calculator to deduce that. So you get 1 minus 1 plus. And now that difference here is actually 1 minus 1 plus will be 0 minus, and the square root of 0 minus, that's undefined stuff. Okay, so therefore the conclusion, okay, so for the two-sided limit, because these two are not equal, maybe I'll write that down to make sure that you remember. So you compare both, okay, they're not equal. Whoa. So, well, hey, so they're not equal. So therefore, the limit as x approaches 0 of the square root of 1 minus ex does not exist. All right, that's it for that first set of examples. All right, the last two examples I'm going to cover in this video, we're at page 47 here. We went a bit forward. Make sure you do look at the other questions, okay, so they're completely solved for you. So now what happens when if you look at the limit as x goes to infinity of ln of x over root x, so if you plug your infinity, you get ln of infinity over root of infinity. Ln of infinity is infinity, root of infinity is infinity. Oh no, okay, infinity over infinity, that's bad. And here, sadly, the square root, ln of x over the square root of x, there's really nothing you can do algebraically. You have no choice. Boom. Okay, we're going to use the numerical approach to guess it. So here you just need one table for x is going to infinity, and you can double check, okay, here with your table, if you plug values that are getting bigger and bigger, that the limit as x goes to infinity, that's just a guess, of course, but that's the only thing we can do here, of ln of x over root of x actually goes to 0. Remember, that symbol here is for a table. I'm not doing the tables. Make sure you try it. Make sure you know how to construct a good table with 3 values, 10, 100, 1,000, and maybe more. And look at the outputs and make sure that they're getting closer to 0. Actually, the same for the last example. If you have to compute the limit as x approaches 0 plus of x ln of x. Again here, even if it's a one-sided limit, you plug 0 initially. So you get 0 times ln of 0. So you get into trouble, okay, because of that ln of 0. And what that ln of 0 is telling us is that now we need to plug 0 plus. Be careful, you need to first identify the bad indeterminate boundary form before you plug in 0 plus and 0 minus. It's a common mistake, okay, that you go too quick. And sometimes you create harder problems. So now if you plug your 0 plus, so here, I'm just going to write down the limit again, but now I'm going to plug 0 plus. So you're going to get 0 plus, ln of 0 plus. 0 plus just goes to 0, and ln of 0 plus, we know it goes to minus infinity. So here we have a bad product between a 0 and an infinite. So that's another bad problem, okay, that we get even by using the strategy which tells us plug 0 minus, sorry, you're still not solving this problem. So what do we do? And here, algebraically, there's nothing you can do. So here we go, okay, numerical approach. Here, you only have to construct one table of values of x's getting closer to 0 on the right side, like for example, 0.1, 0.001, and 0.0001. But you can double check here, make your table, okay, but the correct guess here, the limit as x goes to 0 plus of x ln of x, the 0 will be stronger in this battle between the product of 0 and minus infinity, and you're going to get 0. Remember, this is just a guess. All right, for this video, and here I'm stopping here because all the examples that we have up to that point only involves logarithmic terms or exponential terms. The other examples, we will have also some trigonometric terms, okay, to play with. Bye-bye.